Right, tangent and normal to the hyperbola. So we just looked at all the proofs for tangent and normal to the ellipse, Cartesian form. So we're going to look at now setting out for the hyperbola. So the equation of the tangent at p, x1, y1 is given by x1x over a squared, take away y1, y over b squared is 1. Right, so very similar to the tangent to the ellipse in Cartesian form. So we've got the minus sign for the hyperbola. Okay, so that helps with remembering bits and pieces. Right, let's derive it. So we've got the equations, x squared on a squared, take away y squared on b squared is 1. So that's our general form of the ellipse, centred at the origin, the hyperbola, centre at the origin. Okay, so we're going to find the derivative, and then we're going to substitute a point in there. Okay, so this is where we need to use implicit differentiation. So we're going to do a d dx of all those. Right, so anything involving x's I can just differentiate in normal. If I'm differentiating y's, okay, I need to include the dy dx because I'm differentiating with respect to the other variable. In there, right, solve for dy dx. dy dx is going to be 2x over a squared times b squared on 2y. That's a couple of steps in one. In there. So it's going to be b squared x on a squared y. Yep. Right, so there's our gradients at the point x1, y1. B squared x1 over a squared y1. Right, point gradient formula. Right, so then divide everything by a squared b squared. scroll somewhere. Yep. That should be minus. Yep. Got my sign arrows all over the place at the moment. That should be minus, that should be plus. I forgot to recount when I've swapped things over. It's a bit of a mess at the moment. Alright, so it becomes x1 squared over a squared, take away y1 squared and b squared, and that's of course is the point that satisfies the hyperbola. Okay, so we can set it equal to 1. So to that. Yep. So that's your equation of the tangent at the point x1, y1 on the hyperbola. Alright, null. Alright, so the perpendicular, so the tangent itself was that. So I need negative a squared y1. Good morning. Okay. Hey. Yeah, so you said the next lesson is the working lesson. Yeah. It's probably not going to be now. Yeah. Just make sure we get it all finished. We're getting there, slowly. So I'll just start to skip a couple of questions here and there now. I probably did a bit too much, but I wanted to cover all your bases. Anyway. Sorry, Michaela's pages. Right, let's make sure I get the signs right this time. A squared y1 x plus b squared x1 y is going to be a squared x1 y1 plus b squared x1 y1. Okay. Yep.
The wind is so strong and it's so hot.
It's supposed to be about 40 degrees around this region today. We don't be further up in the northwest, otherwise it's about 42 they're predicting last night. Okay, so divide everything by x1, y1. So we have a squared x on x1 plus b squared y on y1 is going to be a squared plus b squared. Success. Watch those signs, eh? I keep telling you and I keep doing it myself. You what?
We haven't had a lot of sleep.
Yeah.
At all.
We had a big Skype call
from 1 all the way to 6 o'clock in the morning for 5 hours.
Wow, I did not just hear that.
It's done though.
Yeah, the only time I had pulled a very late assignment was about 4 o'clock in the morning. I was in my uni days, but I never had a late high school night. So I must have been more organised than you two.
Kids have got on those.
Then in the end, I didn't do extension 2, so I can understand that somewhat. Alright, so there's your proof. So that is your normal to the hyperbola. Okay, so again, you can learn the formulas off by heart, okay, or derive them, which would be the better bet. There. Alright, so let's try one. So from the hyperbola, x squared take away 3y squared equals 6. So you need to recognise this as a hyperbola, okay, so you need to manipulate it so that you can use the features of it. Okay, so you need to find the tangent and the normal at the point P. Okay, so we're going to do the same proof, but instead of x1, y1, so you're going to use 3 and -1. Okay, we like using numbers. Right, so I need to remember that your right hand side of your ellipse or your hyperbola needs to equal 1 so that you can use a squared, b squared, etc. So, x squared on 6, take away y squared on 2 is 1. Okay, that's the first thing you need to do. Make sure you got it in the right format. Right, so implicit differentiate. You got 2x on 6, take away 2y on 2, dy dx is 0. So anything involving x's we can just differentiate because that's probably our main variable. But anything involving y's, you need to have dy dx because you cannot differentiate the other variable. Okay, so that's why we say it's dy dx. So dy dx is going to be x on 3y. Couple steps there. Okay, you need to take as many or as little steps as you are comfortable with, right? But I've just put it straight into a couple of steps there. So at 3, comma, -1 is going to equal 3 over -3. So -1. Okay.
Is this extension 2?
Yes.
What is this?
Yes.
I understood that.
Right, y minus, so y plus 1 is going to be negative outside of x, take away 3. Okay. Yes, it's going to be challenging extension 2, but it's not supposed to be everything impossible to do. Alright, y plus 1 is negative x plus 3, so y is going to be negative x plus 2. Correct according to GeoGebra. Okay, so there's your tangent. Now we need the normal. Okay, so the perpendicular gradient is going to be 1. So y plus 1 is going to be x take away 3. Y is going to be x take away 4. And that's also correct according to GeoGebra. Right. So we've got P, x1, y1 is pointing in the hyperbola with the focus S. Hang on. Next question. The next part of the question is asked you the intercepts, and then you have to find the distance of the intercepts to the axis. That's pretty straightforward. I won't worry about it. Right, this one's a lot of fun. Alright, so P is the point of the hyperbola with the focus S such that PS is parallel to an asymptote of the hyperbola. We need to show that the tangent at P, the asymptote and the corresponding directrix are concurrent. Took me about 20 minutes to do this morning. Right, so what does concurrent mean? That's collinear. They all intercept at the same point. Okay? Okay, diagram helps. Right, so observe that my x is positive. So I've got my parabola with the foci horizontally, my hyperbola. Right, so I've got the focus. Okay, so I'm picking the point P so that PS is parallel to an asymptote. So remember the asymptote is there somewhere. So the point P on the hyperbola is selected so that it is parallel there and there. What's the coordinates of S? So? No. The 0 part's correct. No. AE. 0. Okay, that will help. We need to show the tangent at P, the asymptote and the corresponding directrix. So let's put the tangent at P. So we're showing that all intersects there. Okay, so the asymptote, the tangent and the directrix all intercept at that point. Alright, you might hear some beeping. Not much I can do about it right now. Alright, so what are we going to do?
Use the directrix.
Yep, so what's the directrix? The directrix, or do you mean the asymptote? Which one did you mean?
I mean both.
Pardon?
Both.
You mean both? Alright, so what can you tell me about the directrix?
The directrix is going to be an x equals.
Yep. Is what? You said it before.
What's the point? A over E?
Foci AE, directrix A over E. Okay, both your ellipse and hyperbola.
What's our x value?
Alright, what else can you tell me?
Something to do with the asymptote.
Asymptote. What's the equation for the asymptote?
I don't know this one.
Something when the denominator equals 0.
Oh yeah. The y equals 0. It's going to be so obvious.
Mm-hmm.
Still you make the box, the rectangle, with this one?
Part of it, yep. What are the dimensions of that rectangle?
Oh,
What's the major axis length?
S. 2S.
I don't remember the details.
Yeah, you do.
2A, 2E on
2A, major axis length, and the minor axis length is 2, no, 2B. 2A and 2B. Okay, so from that, you're thinking about the rectangle at the top. Let's do this corner here. What's the coordinates of that point? Well, if the overall width this way, the length this way is 2A and that way is 2B, and its centre is at the origin, what's the coordinate of the corner there? A?
I. Oh, no.
No, it's not on
Yeah.
I corner A dash B.
Yeah. A, comma B. Right? Well, you're going halfway this way and halfway that way.
This is so obvious.
Right? And the asymptote is the centre and the corner. What's the gradient?
Something
What's the y value?
B.
B. What's the x value?
What's that B?
Line from hub.
Really?
You should know that.
No.
Oh, there you go. You learn something new every day.
There you go. Not in class.
What, you're naming for about, what, 4 or 5 years and you didn't know that? Okay. Right, so we've got some things that we already know. We need to match it up to some other things, okay? So, the gradient of PF is going to be the same as the directrix, the asymptote, sorry, isn't it? Okay. The gradient of the line through PS is going to be the same as the gradient of the asymptote. Alright? So, y take away, I'm going to use the coordinates of the focus for the point of, that goes through. So y take away 0 is going to be B on A, X take away AE. So y is going to be B over AX, take away E. Okay, well, probably could have left it factorised. It'll make things a bit easier in the long run. Okay. So the normal to say will meet the hyperbola at P. Right, so what we're going to do now is substitute the point y into the general form of your hyperbola. Okay, so you're not told anything else about a's and b's. So x squared on a squared plus b on a squared x minus ae squared all over b squared is 1. So we're going to find the coordinate that it meets the hyperbola. Alright, so that will go, that will go. X squared on a squared plus x squared take away 2aex plus a squared e squared all over a squared is 1. So that should be a minus, not a plus. Guys, you need to pick this up here and here. That will be a plus. That will be a minus. Alright, so x squared take away x squared will go. So we're left with 2aex take away a squared e squared is equal to a squared. And you cross multiply. Solving for x. Right, so that's the x coordinate of the point that intersects at the focus, at the hyperbola from the focus. Alright, now we need to have the y coordinate. Alright, what am I going to substitute into? I'm not going to do it in the hyperbola again. Don't make things more difficult than what it needs to be. B over A, x outside of AE. So x, I'm just writing again. Right, so B over A, so x, A outside of E squared plus 1 over 2E, take away AE. Common denominator. A squared should be A squared. Right, and each of my terms in here has an A, so if I factorise and cancel with the bottom, the A's will disappear. So equals B. Now inside the bracket, E squared plus 1, take away 2E squared, all over 2E. Okay, so E squared take away 2, E squared is going to be negative E squared, so inside the numerator, inside the bracket, it's going to be 1 take away E squared, all over 2E. Okay, so what I'm up to. So I've got factorise going to be B outside of 1 take away E squared. Over 2A. Therefore, P has the coordinate A outside of E squared plus 1 over 2E and B 1 take away E squared over 2A. Okay, so the equation of the tangent at P. Okay, so tangent at P, so I could derive it again, alright, but I'm just going to use my result. So x1 x over a squared plus y1 y minus y1 y. So, A, E squared plus 1 outside of x over 2A squared E, take away okay, so substituting my point P into there. Right, so that is now my equation of the tangent at P, not using x1, y1, using what I've already established for P. Right, so the question was to show that 3 things were concurrent. Okay, so we now have the equation of the tangent. we have already worked out, got there eventually, the equation of the asymptote. So we're just going to consider the positive asymptote, so b over ax. So what do you think I'm going to do now to show that everything's concurrent? Yeah.
Set formula.
Just mash them all together.
Yep.
Prove that
What?
they all equal
Same thing.
the same.
Or you can put two together
Yeah.
and then use the third one and make it equal.
Well, don't need to go that far. Okay? You're on the right track, but don't need to go that far. What is the equation of the directrix?
X A E over E.
So if I prove that the two other lines intersect at A over E, isn't that enough to show that everything's concurrent? Okay, so I need to show that x equals A over E for the intersection of the tangent and the asymptote. Alright? So, there's the tangent, the asymptote is b over ax. So if I substitute and solve for x, I should get x equals A over E. Okay? So asymptote. So we're just considering the positive one because that's where I've highlighted my diagram. Okay, so this is now number 2, this is 3, and I'm going to put that into 2. I can simplify it now. Take away b, 1 take away e squared, over 2b squared e times y, b over ax, that's going to equal 1. Solve for x.
Is that supposed to be B squared E?
So,
That second bit where it's cutting out?
get b squared e, yep. So, I don't know why it does that.
Must be sensitive.
Well, I've had to get the older pen because someone nicked off with my new ones. We've never had a problem before until now. Alright, so let's go. That can cancel, square can cancel. And the b can cancel here and here. That helps. So e squared x plus x, because I'm already establishing as well, the denominator is 2ae, 2e times a. So the denominators are the same once I've done my cancelling. Okay, so I'll cancel the a with the a squared, like,
How does that work?
because I've substituted that into, that's my tangent, here and here.
How can you factorise A and then A square out? When you-
I didn't, sorry, just the squared, not the a, sorry. Yep, just the a, not the a squared. Sorry, I meant we can cancel the a on top with one of the a's on the a squared, sorry. B and one of the b squareds here, but I've already got a b on this side as well when I substitute the asymptote. The asymptote, so the other b will cancel. And I'm multiplying 2e by a, so my denominators are the same on the left-hand side. Take away x plus e squared x is going to equal 2ae once I cross multiply. Okay, this is 3 steps in one. Because this is all over this common denominator of 2ae, and then I've moved it up to the other side.
And they cancel it out?
Yeah, okay, so x and x. So we have 2, e squared x is 2ae. X is a over e, as required. Therefore, directrix, tangent at P, and what's the other one? Asymptote. Concurrent. Okay, so I don't really care what the y value is. Alright, I don't need to know what the y value is. You're just showing that intercept. So you show that your two x values intersect at the same point, which is the same point in the directrix. I don't care what the y one is. Alright, I've done enough to be able to answer the question.